Hello and welcome to the lesson video notes for lesson 10.6, volume of prisms and cylinders. Today's objective will be to learn and apply the formula for the volume of a prism and learn and apply the formula for volume of a cylinder. We're going to start by using our warm-up to review how to find the areas of different figures when given certain parts of those figures. So, go ahead and take a moment to start this warm-up, but the first thing I would recommend doing is drawing a picture to go along with each one. Try and draw an equilateral triangle and label the parts of it that you're given. Try and draw a regular hexagon, or at least to the best of your ability. Okay, that's your apothem. We're going to need that for that formula. Okay, a circle with a radius of 6.8. We don't necessarily need to draw that, but you could if you want to. And a circle with a diameter of 14. If diameter is 14, remember the radius is half of that. All right, go ahead and do the warm-up problems, and when you're ready, click play after pausing the video to continue. All right, we should get this. For number 1, 173.2 square centimeters. That is what 100 pi would give us, or 100 root 3, I'm sorry, not pi. Number 2, 509.2 square meters. Number 3, 145.3 square inches, and number 4, 153.9 square feet. All right, let's go ahead and take a look at our lesson. We're going to take a look at the volumes of three-dimensional figures in this lesson, starting with prisms. Now, most often we start with the volume of a right rectangular prism. You guys know what the volume formula is for this already, or you should remember from previous classes. The volume of a rectangular prism is just length times width times height. Okay, but let's expand upon that for just a little bit. If I call this rectangular prism with length L and width W, then the base of this prism is length by width. It's that rectangle on the bottom. Okay, so length times width is the area of the base area, and we're multiplying it by the height. That's going to be the general form of our volume for every three-dimensional figure. I'm just going to take the area of one of these rectangles and multiply it by how many of those flat rectangles would fit, so we're multiplying by our height measurement. So volume of a cube, length times width times height, these are all the same. So volume of a cube is that side length of your edge cubed to the third power. Length times width times height. S times S times S. So of any other kind of prism where we have a base area of B, the volume is just that base area times your height. Okay? So these are the formulas for volume we will be using in this lesson. Make sure you have those copied down correctly. So let's take a look at example 1. Now we're not going to take a whole lot of time with some of these because we just have a rectangular prism. So we'll be using the length times width times height. I want you to go ahead and plug these numbers in and just find what that volume is. You should get that answer pretty quickly. All right, the answer we should get when we do 13 times 3 times 5 is 195 cubic centimeters. And that's how you say cubic centimeters. You write it centimeters to the third power. Okay? For part B, we're talking about a cube where the edge length is 15. That means the S is your edge length of 15. We don't have to draw the picture. You just need to start with the formula. Volume is, for a cube, that edge length cubed to the third power. So when we plug those in, that's 15 cubed. Go ahead and find that with your calculator. We should get that the volume is 3,375 cubic inches. 15 to the third power is that. So let's take a look at a problem that's a little bit more difficult. Finding the volume of our right regular hexagonal prism. The volume formula we will be using is we're going to take the base area and multiply it by the height. So that's what we have to start with. The height is easy to see. The height is the distance between the bases, 12 feet. Okay, 12 feet is your height. But we need to find the base area. The base is a regular hexagon. So once again, we need to know that formula for a regular polygon's area. That is apothem times perimeter divided by 2. So we need to start by finding the apothem and perimeter. Perimeter should be easy to find. 9 feet per side for 6 sides. That perimeter is just 9 times 6, or 54. But then we have to find the apothem. And you have to remember that in a regular polygon, the apothem is that perpendicular distance from the center to the midpoint of an edge. So if the edge is 9 feet, then each half of it is 4.5. And if we remember this kind of triangle, it's off at a slant, but that's still our 30-degree angle. So this is the short leg of this special right triangle. The apothem then is that short leg times root 3. So we can plug those into our formula now. The base area is going to be apothem 4.5 root 3 times the perimeter 54 divided by 2. And when we plug that in and we write everything in terms of root 3, because we don't want to round till the end, in terms of root 3, that should be 121.5 root 3. So we're going to leave that as our base area for now. So once again, take your volume formula. Volume is the base area, 121.5 root 3, times your height, which is 12. So now we just plug it into our calculator. Probably the easiest way to avoid any errors is to do 12 times 121.5 first. 12 times 121.5 first, then times root 3. When you multiply those together and round to the nearest tenth, we should get a total volume of approximately 2,525.3 cubic feet. You notice we say cubic instead of squared, because volume is a cubic measurement. All right. For our application problem, we're going to do part of this now, and then we'll finish the rest of it in class. So your task right now is just to find the volume of this swimming pool as a rectangular prism. We have a length of 25 feet, width of 15 feet, height of 9 feet. Go ahead and find the volume if it were to be completely filled to the top with water. Okay, the volume we should get when we do 25 times 15 times 9 is 3,375 cubic feet. Now what we're going to have to do from here, and this is the part we'll probably go ahead and do in class, unless you want to try and work ahead on your own, we need to convert that from cubic feet to gallons of water so that we can figure out the density of the water in total. Okay, and I want you to try and figure that part out. They give you all the conversions you need. So every gallon represents 0.134 cubic feet. And then once we have our number of gallons, we're going to multiply by 8.33 pounds per gallon to find the weight. Go ahead and try that, and we'll check our answers in class when you get back to class. Okay, now we need to move on to talking about volumes of cylinders. There are two basic measurements of a cylinder, the radius of the circle and the height. Remember, in general, the volume of a three-dimensional solid is the base area times the height. Okay, since volume is still base area times height for a cylinder, the base is a circle. So the volume is the area of a circle, pi r squared, times the height. And that works whether it is what we consider a right cylinder or an oblique cylinder. It still works. So let's take a look at example 3. Like I said, we've got an oblique cylinder here, so that's still going to work. We're going to take the area of your base and multiply it by the height. The height is this perpendicular measurement, not the slanted edge of this lateral surface. But notice that they ask you to give answers in terms of pi and rounded to the nearest tenth. That means there's going to be two parts to each answer we put down on paper today. So let's take a look at part A. We're finding the volume of a cylinder, so we need to start with that volume formula, which is pi r squared, for the area of the base, times the height. So we need to know the radius of this cylinder. Well, if the diameter is 18, the radius is half of that, 9. The height is 14. So I want you to take these measurements and plug them into your formula, and then write your answer in terms of pi, cubic inches, and then also round to the nearest tenth cubic inches. When you are ready to begin, go ahead and push play. Alright, these are the results we should get. 9 squared times 14 gives us 1,134 pi cubic inches, and when we round that to the nearest tenth, we have 3,562.6 cubic inches. So both of those together is how you would expect to write your answer. Alright, let's take a look at part B, though. On part B, we are given a little bit different set of information. A cylinder with a base area of 121 pi and a height equal to twice the radius. So here's what we need to do in this case. The cylinder given has a base area that's already known in terms of pi. But I need to know the height still. Remember, volume is base area times height. It says the height is equal to twice the radius. That means we need to know the radius first. Well, if the area of your base is 121 pi, remember that area of a circle is pi r squared. That means 121 is your r squared. Since r squared equals that 121, r is the square root of 121, or 11. It says the height is twice the radius. So if the radius is 11, the height is twice that, 22. Now you know your height. We already know the base area. We just plug those into the formula. Again, writing answers in terms of pi and rounded to the nearest tenth. These will be in cubic centimeters. Go ahead and take a few moments to do those calculations and check your answers. If you need more time, push pause. Otherwise, these are the results we should get. In terms of pi, we get 2,662 pi cubic centimeters, which rounds to about 8,362.9 cubic centimeters. Alright, let's briefly talk about changing dimensions. When we change dimensions for surface area, we squared the factor by which we changed our dimensions. For volume, since volume is a cubic measurement, we are not going to square that. We are going to cube that measurement to the third power. So if our dimensions are multiplied by some value a, the surface area will be multiplied by a squared, but the volume, since it is a three-dimensional measurement, is multiplied by a cubed. And we will expand upon this in class a little bit more, but for right now, we can tell that if we're multiplying all the dimensions by 2/3, the volume is multiplied by 2/3 to the third power, or 2 to the third is 8, 3 to the third is 27. Okay, you'll notice there's still another example in your notes. We're going to save that to talk about in class when we talk about composite figures. And we should be able to get the rest of your notes filled out in class. We'll also be posting, I'll also be posting the homework assignment to this if you want to go ahead and get a head start on your worksheet. Otherwise, you should be well on your way to understanding volume of three-dimensional solids, including prisms and cylinders.